Well, good evening and welcome to Tracking the Tropics, your weekly in-depth look at the hurricane season and how it will impact you. I'm CBS 17 meteorologist Brian Hutton Jr. in Raleigh, North Carolina, and this is week 6 of the Atlantic hurricane season and the start of our second month of the 2020 Atlantic hurricane season as well. Here's what we have for you on episode 6 of Tracking the Tropics.
I'm meteorologist Jeff Edmondson in Norfolk, Virginia, and I'm going to be talking about buoys, and they're actually more exciting than a spot for birds just to sit on in the middle of the ocean. They're floating weather stations, and they're really important to hurricane forecasts. So we're going to talk about the buoy network.
I'm WGNO meteorologist Scott Pilier from New Orleans, Louisiana. Tonight we're going to be talking about storm surge, one of the biggest impacts from a tropical storm or hurricane, and contraflow, one of the biggest concerns here along the Gulf Coast. Full details coming up tonight.
We have a lot of good stuff in store for you tonight. First, though, let's check in where we are in the hurricane season and what's happening currently in the tropics. It is, after all, July, and about this time of year, we should start seeing an uptick. Right now, though, things are fairly quiet, but there is something we're keeping our eyes on. We'll check in on that here in just a second. First, here's our tropical climatology as we head through the season. As I'm sure just about all of you know, our peak is September 10th. That's when we hit the peak of hurricane season, both for tropical storms and hurricanes, September 10th. We are, of course, July 7th, so we are not even quite to the upswing yet. That usually happens in August, but it has been a busy season so far. If you've been paying attention, we've been very busy here on Tracking the Tropics. We were fearful we wouldn't have much to talk about this early in the year. Well, that has not been the case. We've gotten off to a rip-roaring start. That's kind of a summary. Let's see, because there is an update. Let's see what our forecasts were. North Carolina State, one of the agencies that issues a preseason hurricane forecast, expecting 18 to 22 named storms this year, 8 to 11 hurricanes, and 3 to 5 major hurricanes, which is obviously above average of our 12, 6, and 3. I actually spoke with one of the professors of the NC State team this week, and they said they are not going to update their preseason forecast. They expected a hyperactive season, and well, so far that's what we've seen. Colorado State, one of the other main agencies that produces an early season forecast, today had their first update to their preseason forecast, and they bumped their numbers up just a bit. They're now forecasting 20 named storms, 9 hurricanes, and 4 major hurricanes, which you see falls nicely in line with what NC State forecasted earlier this year. NOAA, the official preseason hurricane forecast, 13 to 19 named storms, 6 to 10 hurricanes, and 3 to 6 majors. So you see everybody pretty much general consensus across the board. This should be a very active season, and that's been the case so far. 2020 setting records. We were the fastest season to 3 named storms and the fastest season to 5 named storms. Hopefully, we're not also the fastest season to 6 named storms. Out across the Atlantic, things are fairly quiet. There's a cluster of thunderstorms moving across the Virgin Islands and the Lesser Antilles now, just south of Puerto Rico, just some thunderstorms there. You can see the nice cloud band that's stretching through the tropical Atlantic. That's the intertropical convergence zone. Of course, it should be active, and there are some thunderstorms there, but nothing organized. Gulf of Mexico, fairly quiet, except for a weak kind of front drifting southward out of the continental United States. And then there's a lot of cloudiness across the southeast U.S. This is where our area of concern is as we head into the upcoming week. National Hurricane Center gives this system about a 40% chance developing as we head over the next 5 days. The main question mark with this system is not really if it develops, is does it even get over open water? A lot of models are struggling with the idea of this actually emerges far enough out in the ocean to try and develop. Some models keep this pretty close to the North Carolina coastline and then up towards the Virginia coastline as well, and as you head towards the Delmarva Peninsula. So there's a question as to, does this thing even get into open water? If it does, the water is very warm for this to develop. Now, normally this time of year, we talk about the Gulf of Mexico, the Western Caribbean, and the Southwestern Atlantic, where systems try and develop this time of year. As you can see, ocean temperatures are pretty warm. You know, several 80s, near 90 degrees as you head towards Florida. It's even in the 80s around Puerto Rico. Also in the 80s just off the southeast coast. That's the Gulf Stream, this kind of red line you see here. That brings all the warm water from the Gulf of Mexico out into the northern portions of the tropical Atlantic. So it's warm, and our system that is forecast to try and move offshore will encounter some very warm waters for a while before it starts drifting north of the Gulf Stream, and then any chance of developing will not be there. So this does have a shot if it can get over open water. But again, that's really kind of the key when watching this. And one of our models here will walk you forward with this, kind of keeps the idea that this likely isn't really getting out into the open water. We'll move forward here to Thursday afternoon, and this kind of tries to develop this into an area of low pressure, but you notice it moved it right along Dare County, which are the outer banks of North Carolina, and then moves it up towards Virginia Beach and Norfolk, and then up as you head towards the Delmarva Peninsula. Also moves it northward then through portions of Maryland and Delaware, and then moves it kind of hugging the coastline northward towards New York State itself as well as we head towards Friday. So not optimistic that we'll see anything tropical develop out of this, but of course we will keep our eyes on it. That's what we are here for. But hopefully we don't see our 6th named storm for a while. But the way this season is going, anything that has a chance, we need to definitely keep our eyes on. All right, now it's time to get to our first guest. If you've been out in the ocean, you've come across a buoy. Now, these aren't just something for birds to sit on. They're weather instruments used to collect data within the world's oceans. For more on that, let's welcome in Wavy meteorologist Jeff Edmondson. And Jeff, many people probably have not heard of the impact buoys have on our weather forecast and how they help us during tropical storms and hurricanes. So give us a breakdown of how the buoy system works and how they assist us during times of emergency.
Yeah, exactly. Yeah, they're really important. And the one thing that we actually don't hope for, we don't want birds to sit on them because they're going to sit on the anemometer where we get our wind speed and wind direction from. If they're sitting on that, they're just spinning it around so we get bad data. So hopefully that doesn't happen, but it tends to happen. There's deterrence for them. But anyway, let's talk about the buoys. Now, here's a picture of a buoy right here, basically a big chunk of metal floating in the ocean. We have the anemometers on it. We have solar panels on it to keep it powered because we're not running extension cords to this thing out in the middle of the ocean. So it has to be a self-sustaining weather station, and that's what it is. And weather stations don't need a lot of power. And when they're floating in the ocean, they have plenty of sunshine. They have plenty of energy to keep themselves powered up. But we keep an eye on all of them. And there's more than 1,000 buoys worldwide in the network, which is great. It's not a lot. There could be a lot more. It would help us out if there were more of them, but we do have a good amount of them, at least across our part of the world. They measure a lot of things like the temperature, the air temperature, and also the water temperature. That's important too because we want to know how warm that water is. You just saw Brian talking about that for tropical storm and hurricane development. That's really important. It's not just the air temperature in this case. The wind direction, the wind speed, of course, when we have a big storm system out over the ocean, when a storm eye maybe passes over a buoy, before the buoy breaks, we can maybe get some of those wind speeds from that so we know what the surface winds are, which is great. Also atmospheric pressure too for how strong those storms might be. So this is a look at where all of the buoys are, and it has all of the locations, even into the Great Lakes as well. So that's where we count. But not all of these are buoys. Some of these are actually ships or ocean oil platforms. And we have information from those too. So they have the same weather station on board. Now the ships, of course, move, so that data can change, of course, and they shouldn't be within this eye of the storm at the time, but they can be, of course, in an area where the storm may be passing, so we can get some information ahead of that, which is helpful. Tons across the Gulf of Mexico, of course, also plenty across the East Coast, through the Outer Banks, in our area, into the Chesapeake Bay as well, further to the north towards New York City, all the way to Maine, past Nova Scotia, and also into areas across Canada. Some of them also in the Central Atlantic. So they're everywhere. We kind of get that idea, and they give us a lot of information. Now, of course, sea surface temperatures are important. We talked about that a little bit ago, but once again, we have temperatures in the 80s. That's important to know because if that storm system that's over Georgia right now and parts of the southeast slides over the ocean, well, the ocean's warm enough for that thing to develop because we know that from the buoys. Now, the waves. This is the important topic because it's not just the waves for surfers, it's not just the waves if you want to go to the ocean and there's a threat for rip currents. Also very important too for boaters as well and for any other maritime industry. Now wave heights, of course, that definition, the height of the waves. Easy. The wave period, you may not know, it's the time between each wave. So we can have two different types of wave period that we look at, that mariners will look at, and also just important for anyone else. Shorter period waves around 5 seconds basically means that waves are coming in every 5 seconds. So there's a fresh wave every 5 seconds, so that's a short period. Now a longer period could be about 12 seconds, and that's better for boaters. They can handle that because the ocean is generally slowly going up and down instead of whoosh, whoosh, up and down really fast. So that's a better thing if we have a longer period. Now, Also, of course, for surfers too, that's better as well. It's easier for them to paddle out in. So waves can also be fun as well. I'm a surfer myself, so I like when they're longer period waves. And we get those from distant storm systems, not ones right on top of us. Again, we've been watching the southeast for any possible development. We talked about that a little bit ago, but I just wanted to show you kind of the broad picture again, because what creates the waves? Well, it's the wind. As that wind goes across the top of the ocean, it has a little bit of a friction. It grabs that water. It creates the waves, and that's what we're seeing develop here. Now, normally in July, we don't see storm systems like this. It's usually a quiet month across our area, and for wave heights especially, I know as a surfer, there's not a lot of waves. So storm systems like this, since they're not going to cause a major impact, it looks like right now, at least to much of our region, the waves certainly are something that a lot of us are watching. If you want to do some boating or you want to do some surfing, you want to watch the forecast closely because that'll be the area of the most impact. Now, the storm system likely lifts through our area, sometimes Thursday and into Friday, at least for areas into North Carolina and Virginia is what I'm talking about. Here's a look at the wave height forecast. Once again, we have all of our buoys out there. The ones closest to the coast will likely see the biggest waves because that's where the storm system and the strongest winds are going to be to create those maybe 8-foot swells or 4-foot swells. Now, one thing to keep in mind, the waves at the ocean are not going to be 8 feet tall. They get smaller than that. Why? Because they run into the continental shelf. We have a lot of terms going on here, but I hope this is making sense. Now, the continental shelf is this area in this light blue color that you see all across North America. It's basically an area where the water is a lot more shallow than it is in the middle of the ocean. So for us, once again, we have that shelf. And that does do a lot of protecting across many areas if the storm is distant. Now, if it's right on top of us, it doesn't really help. But basically, it's an area that's submerged, part of the continent. The water is about 100 feet to 2,000 feet deep. So it does get kind of deep, but considering where it is in the middle of the ocean, it's totally different than where it is along the shelf. Now, Kenny rode those waves. Here's kind of a simple diagram of it. Here's the middle of the ocean. Here's the shelf. So there's a thin layer of water here that erodes the wave heights a bit, and it protects us. Now, there are some areas where it sticks out a bit, and we've had problems with that. So we're going to go back a year to Dorian. We know all about Dorian, how it made those major impacts across the Caribbean areas and just off the coast of Florida. But remember, it turned back up the coast and it went right over part of our area, over Cape Hatteras. And that's an area, if you've ever been down there or if you haven't, it's a thin strip of land for the Outer Banks. You look to the left, you see the ocean. You look to the right, you see the Sound. It's a really thin strip of land, and it doesn't take much for waves to go over on top of that. And that's what happened in that particular area. There were high wind gusts around 90 miles an hour. We had severe flooding. Basically, part of the roadway here, which is Highway 12, was overwashed by the high waves that we had that were around 12 to 15 feet. So that's why we really have to watch for these wave forecasts, and the buoys help us out with what's going on. So that's part of the problem when we have the big storms right along the coastline, that ocean overwash, at least for our area. But again, we're keeping a close eye on this. Things are looking okay. I don't believe we'll get the ocean overwash from this type of storm system. It's looking a little bit too weak, but that's where we are there. Hope the buoy talk made a little bit of sense. Let's send it back over to you, Brian.
Thanks, Jeff. A lot of great information there. And, obviously, as meteorologists, we deal with the lack of data flowing in from the tropics because nobody lives in the middle of the ocean. So how can the buoys help tell us about storm structure and storm strength? You mentioned about the wave height. How does that help us in terms of how strong the storm actually is before it gets to land?
Yeah, it's really important because we can, if we have really tall waves, really big waves out over the ocean, and our satellites can't tell that and can't figure that out, we can get that extra information. And sometimes that information can also go into our weather models as well to help enhance those forecasts for everybody so we can get a better idea on where the storm system is, how strong it is right now, and maybe if it's going to be getting a little bit stronger.
You mentioned you're a surfer, so waves is something that obviously definitely you pay attention to. What do you find when you talk with people who are also out there who aren't meteorologists? What is the most important thing they're looking for, whether it's about the waves or something that you may have mentioned that you custom in your forecast when they're trying to get out on the water?
It's really important too because it's not just the wave heights, it's the wind direction. So if we have in our area a northeast wind, that would be an onshore wind. So if you're standing on the beach, the wind is blowing at your face. When waves and the wind is like that, then it's really choppy. But if the wind is the opposite direction, if it's at your back and you're looking out towards the ocean, then the waves are cleaner, they're smoother looking. So for surfers, at least, that's better. For boaters, though, it just depends on what type of craft they're operating, because wave heights of 3 feet could be a big deal or may not be, depending on the size of the boat. But they're always critical because things change often in the bay for us and also into the ocean.
Fantastic there. Make sure I take my yacht out with you. The yacht that I don't have. Jeff, thanks so much for spending some time with us tonight. That's Chef Edmondson up at Wavy 10 there in Norfolk, Virginia. If you're in the area, definitely make sure you check him out. That's fantastic there. No, he was a surfer, learning something even new here on Tracking the Tropics. Here's where we are with our 2020 storm names. As I mentioned, we're down now to 5. Edward formed on Sunday, becoming our 5th named storm, the earliest ever. We've made it to 5, beating the record set in 2005 by Emily. Emily formed on June 12th. Edward formed on July 5th. So we beat it by almost a week exactly, actually. And again, next storm on the list, if the system we're watching in the southeast develops, it would become Faye. Faye is storm number 6 named for us. Hopefully, though, it's a while until we get there. As I mentioned, our climatology, though, we're starting to ramp up. Here's a look at activity by month over the last about 2 decades, from 2000 to last year. In July, we've had 28 named storms over the last 20 years. Of course, we ramp up into August and September as we get into the peak of the season. Even October, as we come down to the back end, still has seen 55 named storms in the last 20 years. So it's not a surprise we see storms in July. Hopefully, though, again, we keep things quiet for a while. It has been an extremely active season. It's not just active in the Atlantic. There's one other basin that's out there, which is the Eastern Pacific. If you look across the Eastern Pacific, there are actually a couple of areas of concern that the National Hurricane Center is watching, but there is actually one named storm. Now, normally by this point, the Eastern Pacific is well ahead of us with names. They actually go through all 26 letters of the alphabet. We only have about 20 or so. This is Tropical Storm Kristina. Winds are at 45 miles per hour, and for reference points, about 415 miles due south of Manzanillo, Mexico, and is forecast to move off to the north and west. It will become a Category 1 hurricane as we head towards Thursday, perhaps even becoming a Category 2 before it heads out to sea and will begin weakening as we head to the weekend. So one of the good things with this one, we don't have to worry about impacting anybody heading out to sea. But as I mentioned, there are a couple of areas that we are concerned with in the Eastern Pacific, but right now, no threats to land. Let's get ready now for our second guest tonight. And whenever we think of hurricanes, we hear about the term storm surge, which is described as an abnormal rise of water generated by the storm. And it's often the greatest risk to life and property from a tropical storm or a hurricane. Now, you may be familiar, one term, though, you may not be familiar with is contraflow. Something, though, if you live along the Gulf Coast, I'm sure you are familiar with. So with more on that, let's welcome in WGNO meteorologist Scott Pilier. I got it right. Did I get it right? More on
yes.
that.
Yes. Yeah, I'm impressed.
I've been practicing.
Yeah, good. Little Cajun name, a little bit of a French name there.
I figured. So tell us about storm surge and contraflow, Scott.
Hey, yeah, so, you know, what I wanted to put into this was kind of that we already dealt with this, and I'm sure you talked about some of the named storms that we've already seen, of course, in the Atlantic Basin, one of which actually made landfall here in my DMA in southeast Louisiana. So this is what we saw earlier this year. This was the impact of storm surge, really a high impact event for storm surge here in southeast Louisiana and South Mississippi. Again, this was from Tropical Storm Cristobal earlier in the year. And this is one of our really vulnerable cities that we have right outside of levee protection. And this was the impact, storm surge from a tropical storm. So, you know, we always kind of talk about the fact that it doesn't need to be a strong storm to cause a big impact, especially in really vulnerable coastlines. So storm surge, again, you kind of touched on it, Brian, a little bit, is that storm surge is a wind-driven rise in water. But here in southeast Louisiana, if you have a persistent southerly wind, we have problems from storm surge. You can have coastal flooding of 1 to 3 feet, even with 2 to 3 days of southeasterly winds. So the big thing we always kind of stress here is that regardless of the storm's strength, if it's a slow-moving storm, even a tropical storm, or if it's a large tropical storm or hurricane, those two impacts, those two factors really can make the storm surge a way bigger impact. Now, again, storm surge is one of the greatest risks to life and property because it is kind of a gradual thing at first, but when the storm gets closer, if it's a longer duration event and a slower moving storm, you can really see the storm surge pile up on areas that have a more shallow coastline, which we have here, a lot of marshland. But thankfully, the storm surge with this system wasn't of an impact for any areas outside or inside of levee protection. This was all outside and along the Mississippi coast. But again, the motion of the storm, yeah, slower motion, greater storm surge. Also, if you have the size that is larger, that causes a greater influence of wind over a larger surface area of the water, and that can really pile up the water as well. And that last factor, the strength of the storm, does play an impact. Obviously, stronger storm, faster winds, larger storm surge, and we've had many storms here in South Louisiana that have given us some really historic impacts in terms of storm surge. Now, we were also talking about this, some terms that people haven't heard of if you're further inland is something that we call contraflow. In South Louisiana, we have evacuation phases that take place, and this kind of ties right in to the term contraflow. For those of you who aren't familiar with it, contraflow is basically a reversal of all of your lanes of traffic to one lane. Contraflow, you combine all those lanes to one direction. Here in southeast Louisiana, there's the three phases. You can see phase one along the coastal areas. That's generally outside of levee protection. Phase number two has some form of levee protection, and it's further inland, and that would be the phase two that usually evacuations take place about 40 hours ahead of time before the onset of tropical storm force winds and storm surge, because again, these evacuation phases tie really directly into the storm surge. You're really, more often than not, going to be impacted by the water rather than just the wind. And then you can see this third phase, the red area, that encompasses much of metro New Orleans, basically from the I-10 to the I-12 corridor. And the reason that I mentioned the interstates is because that phase three, the New Orleans metro, whenever you get within that 30-hour time span of when tropical storm force winds and coastal flooding could begin, that is when contraflow begins. And I use these arrows to kind of show you the main routes out of town during a big storm here in southeast Louisiana. It's only happened twice. In the 2000s, we had Hurricane Katrina, of course, and in 2008, we had Hurricane Gustav that made landfall just west of the area. And that caused significant storm surge, not enough to topple any levees inside the metro area, thankfully. But again, the contraflow areas you can see here, I-10 westbound, conjoins into one lane. You've got I-55 basically in between Lake Pontchartrain and Lake Maurepas. That goes north. You've got the causeway. You can kind of see it over Lake Pontchartrain. That takes you to I-12 and then north. And then you've got I-10 that conjoins to I-59. So again, contraflow is basically getting all people out in as quick of a fashion as possible, Brian. So hopefully we don't have to talk about contraflow. We've only had it twice here in the past 2 decades, but yeah, hopefully not anytime soon.
Yeah, that's definitely true. I remember driving home from New Orleans and noticing on I-59 where they have it apparent where they can break the contraflow as you head northward up towards Hattiesburg. And as you mentioned, I know a lot of states, obviously Louisiana being one of them, have designated contraflow routes already established. Does the projected path of the system change how they do contraflow routes, though, as the storm approaches?
Yeah, no, that's a great question. So we actually do have, changes that can occur, especially when a storm changes path. Typically when you have a storm that's making landfall to the west or projected landfall west of our area in particular, then obviously less people would be heading out towards the west if that's where the location of the storm was expected to make landfall. So yeah, they actually will open up more lanes accordingly. But typically these areas, the causeway, the twin span, I-10 west, those are kind of our 3 routes out of town. But if you're not taking one of them, then they may extend the duration of the lanes. Like you said, you were heading towards Hattiesburg. They may have that lane opening of more lanes, all lanes out, open for a longer stretch of highway. Does that make sense? Kind of a longer stretch of highway open with more lanes
That
going out.
That does. And if anybody, especially from your area, has driven northward on I-59 towards Hattiesburg, you can see kind of, again, as they stagger along, where they let the Contraflow kind of come to an end, as you mentioned, depending on the distance there. So that's fascinating if you're driving in that neck of the woods to see there. The other thing you mentioned there, storm surge, it's often a forgotten killer. A lot of people think wind, they think the flooding. Storm surge, though, not always necessarily the case. So especially on the coast there, what are some agencies doing to help ensure that people take storm surge seriously?
So, the BP oil spill back in 2010, obviously a huge economic and basically a huge impact all along coastal southeast Louisiana for a lot of people with business down there, and especially for, our coastal wetlands, the health of the wetlands and stuff like that. But in response to the BP oil spill and Katrina, obviously, the state got a lot of grant money. And thankfully, they've been doing an incredible amount of projects. The CPRA, the Coastal Protection and Restoration Agency, has had a huge kind of master plan. And it started after Katrina, but more so in the past decade or so, they've implemented master plans that kind of take 5 years or so that they complete. And one of the big ones, I just have this map here, and this is actually a snippet that I made earlier, but over 300 miles of levees have been repaired. They've done a huge amount of impacts with the amount of wetlands that have been refurbished or actually dredging on the Mississippi River. They'll dredge the mouth of the Mississippi River, take that sediment, and put it right back into our wetlands. So the CPRA is one of the agencies that, especially for the state and for the coastal wetlands, it's a great platform to follow on Instagram, too. If you're into all the ecological impacts that storms can bring to the area, follow them on Instagram. You've got to see it because they'll post stuff about the brown pelican population, that they actually have done, ecological projects to rebuild some of these wetlands that in turn, house fish and shrimp and oysters and pelicans. So really cool agency, and they do a lot of great things.
Yes, and if you have ever been to New Orleans, you know how important the seafood industry is to everything.
It's dinner time, right?
I might have to get some seafood now. It's my dinner time, too. And I'm an hour ahead of you by time, so I am very hungry. Scott, thank you so much for spending time with us tonight.
Thank you, Brian.
Stay safe down there in the bayou. That's Scott Pillier. That's my new favorite last name, by the way, from New Orleans, Louisiana, bringing in all of that great knowledge. Fantastic job. Thank you, Scott. And thank you, all of you, for spending part of your night with us here tracking the tropics. I appreciate it. I'm sure Jeff and Scott do as well. We're here every Tuesday night at 8 Eastern throughout the Atlantic hurricane season. Live in Raleigh, North Carolina, I'm Brian Hutton Jr. Have a great rest of your Tuesday.